and evaluation of tracks, wagon and ancillary parts within the railway industry. Currently, there has not been any railway entity standard in Nigeria. Therefore, companies that are engaged in construction of railways, manufacturing of ancillary parts or maintenance and laboratories, known as the Giant of Africa, need to harmonize and verify other standards and regulations within the West African and African corridors. The railway industry is governed by various international, regional, and national entity standards, procedures, and codes. Some of the NDT codes at the international level are the ISO 6933, which is the railway rolling stock material magnetic particle acceptance testing. We also have ISO 5735, railway infrastructure on non-destructive testing on railway tracks, part 1, which is the requirement for ultrasonic testing and evaluation principles. On the regional environment within the European nation, there are a lot of standards within the European nation on NDT railway practice. So within the European region, various entities, various standards that are aimed to ensure safe operation of railways have been legislated and adopted within these countries. For instance, EN 16910, published in 2018, is a standard for railway rolling stock, which have requirement for non-destructive testing on running gears. We also have EN ISO 9712-2012, which is for training of the personnel and manpower. We have BSEN 473-2008, which is non-destructive testing qualification certification of NDT personnel. General principle. We also have BSEN 12668 series, which has verification of ultrasonic examination equipment. We also have BN ISO IEC 1702-2006, which is a standard for confirmation assessment requirement for bodies providing audit and certification of management system for NDT. We also have BSEN ISO 9978-2022, which is for radiation protection, seal sources, leakage test method. We also have BS ISO 4386-1-2019, which is plain bearing, metallic multi-layer plain bearings, non-destructive test for ultrasonic testing of bond of thickness greater than or equal to 0.5 mm. We also have BSEN 17290, published in 2021, for non-destructive testing, UT examination for loss of thickness due to erosion or corrosion using advanced method of TO, time of flight diffraction technique. So this standard, the entity standard for railways are within the European nation. These are regional standards. Then currently in country, Nigeria, we, as I've said, we do not have any standard on NDT railway testing method. But we have, INDT have tried over the years to have some NDT certification or standard within the Factory Act, the guideline for qualification of industrial radiographers in Nigeria, though not specifically on railway systems. But within the African nation, South Africa has done so much on NDT railway. So we find in South Africa Railway Safety Management Standard, SARA 001. We also have Railway Safety Management. We also have Technical Requirement for Engineering and Operational Standard. We also have SARA 003, which is Technical Requirement for Engineering and Operational Standard, Track, Civil and Electrical Infrastructure. Regulation on Railway Safety Standard and Development and National Railway Safety Regulation Act. Australia also have QE. Australia also have various standards on NDT railway, which Nigeria needs to do something about it. And that is the sense of where we are, yes, for us to be informed that we have a lot of enormous tasks to work as INDT and Nigeria too. NDT standard employed on rolling stock and tracks. The following is a standard typically used on rolling stocks and tracks. First, we have the European standard EN 16901 for rolling stock. We have the national standard EN 27201-7 condition of railway vehicles. We also have written down and adopted by European nations 13260 published in 2020 railway application, wheel seats and bogies, wheel seats production and requirement. And there are so many other standards. So the essence of identifying or bringing these standards is to ensure and to encourage us in Nigeria for us to develop our own standard. We will not be requiring on foreign standard to finance or to supervise our railway in Nigeria. Having noted that we have borrowed a very humongous amount of money to finance these assets. So if we leave it without regulating, without legislating standard, there means we are playing, because these monies are not our monies. These monies are borrowed funds. Okay? Establishing standard railways operation in Nigeria. Nigerian Railway Corporation is saddled with the responsibility to regulate the industry by developing regulations, procedures, standards, and codes to cover the total operation of Nigerian Railway. The railway standard, codes, regulation, and specification established the governance arrangement for the safety management of railway inspection in Nigeria. So we have in Nigeria, we have Nigerian Railway Corporation Act, Part 10, Section 50 to 56, and Section 59, which gives the Nigerian Railway Corporation power to make rules, and hence collaborating with INDT and other stakeholders in Nigeria will help us as a nation to actualize this important segment of national asset preservation. Technical expertise on NDT skills. Federal government established a facility for the assembly and manufacturing of wagons and rolling stocks at Professor Sibanjo train station, Kajola, Ogun State, which is a boost for an in-country technical capabilities aimed to reduce capital flight and monopoly of original equipment manufacturers and increase maintenance, time and efficiency rate and safety of Nigerian railways. So what this means is that the government has done that, but we need backing, we need skills to ensure that we start producing our own locomotives, start producing our own cars, which is very, very important. Now, one of the major issues related to the maintenance of railways, locomotives, rolling stock is the need for parts and lack of sufficient skills and skilled personnel to man this industry. It is acknowledged that the key to the success of railway industry is availability of qualified personnel, since the test conducted in NDT realization. Therefore, NDT personnel with diverse skill sets and experience are great asset to the nation. Aside the Nigerian Railway Corporation Technical Institute in Yaba, Lagos, there is the establishment of Federal University of Transportation in Dara, Katsina State, and the Nigerian Institute of Training Technology and Transport Technology in Zaria, Kaduna State. These two transportation railway institutions in Nigeria does not have NDT training courses. In order to ensure the safety of movement and parts replacement of rolling stock that is highly needed to drive the railway industry, training is. And we all know that what is worth training, according to Pastor Chris, what is worth doing well is worth training for, according to Pastor Chris. The role of INDT in railway monitoring. There is need for collaboration with the government, the academia, and other relevant agencies to regulate NDT standards, education, training and certification, research and development to produce NDT equipment, parts, and also to regulate and ensure railway safety and integrity compliance is maintained. INDT need to develop NDT curriculum in Nigerian polytechnics and universities for educating, leading to graduating building NDT equipment, leading to graduates building NDT equipment, theories and programming languages, and curriculum in training and certification leading to skills personnel in line with ISO 9712. What this means is that in Nigeria we need to have a curriculum whereby you can graduate with BSc in NDT, and that will help us to start having algorithms, having systems in place that will help us to have equipment rather than the work we are doing only on training on how to use the equipment manufactured already by the original OEM in various foreign countries. So INDT and government establishments like NITT in Zaria, Kaduna Railway, Rail Wagon Assembly Plant in Ogun State, and National Center for NDT that is located in PTI, and even the PTI and other federal government establishments need to synergize for us to achieve this. Nigerian Railway Corporation, liaising with INDT and other relevant stakeholders within the railway industry, also is required to develop NDT standard codes specification to ensure safety routine maintenance, which will ensure uniformity in the management of Nigerian Railway, since state governments are already venturing into railway operation, so that we will not have catastrophe in railway monitoring. The Nigerian government is advised to encourage professional institutions to undertake roles in providing expertise so as to make greater input to improve both a challenge and INDT need to bridge in the gap. Also, Nigeria as the big brother in the African family need to domesticate international standards and harmonize or unify other regulations within various sub-regions of Africa to aid in regional railway connectivity and establish an establishment of African original equipment manufacturing companies. Conclusion. This paper discusses briefly the current state of Nigerian railway, the defect affecting its rail tracks, and the importance and proven role of using NDT testing method as the most appropriate measure to mitigate defects and possible unforeseen challenges to ravaging the Nigerian railway system. Calls for synergy among academia, INDT, and other institutions with the Nigerian government in collaborating with the Nigerian Railway Corporation to ensure frequent use of non-destructive testing of the railway infrastructure. Legislate and create standards and procedures binding these test methods in order to build the required integrity of railway infrastructure, which will ensure thereafter that safety and economic growth of Nigerian economy, hence prevent any failure that may arise or that may lead to unimaginable consequences or loss. It is therefore hope that this paper on the role of NDT as a pivotal tool, the Nigerian railway safety will in no doubt be prioritized by the Nigerian government and other relevant agencies to end the incessant challenges emanating from inadequate rolling stock, rail track defect, and hence improve the efficient rail transportation system in the country. Recommendation. Considering the defect and various unforeseen challenges affecting the rail track in Nigeria and the importance of using non-destructive testing methods in mitigating them, the following approaches or recommendations become necessary. 1. Harmonize NDT training centers and industry-wide training for NDT operators and towards enforcement, regulating and implementing of NDT railway standard. 5. While on long-term basis, the Nigerian Railway Corporation should work harmoniously to establish national railway safety and testing laboratories in the various 6 geographical zones of the country. 6. These recommendations are made in an attempt to improve the rail inspection within the Nigerian Railway Corporation and reduce costs, both in terms of money and lives, and also railway-related accidents It is therefore hope that railway entity will serve the industry more and will continually do so if its impact is enhanced and improved, and improvements made following these suggestions. The last recommendation, that unification of railway entity inspection standard will enhance regional and territorial railway safety with Nigeria and other Western African regions. Finally, the authors opine that to ensure the Nigerian railway safety, which is largely dependent on the application of NDT and NDT best practices, should be done by qualified professionals. And in furtherance, believe that these techniques, if used properly, will mitigate sudden failures and defects emanating from rails, thereby ensuring safe train ride, which is safely within train networks of Nigerian Railway Corporation in Nigerian states. These are references. Thank you for your rapt attention.
Another resounding round of applause there. And that was a technical presentation on NDT as a pivotal tool in maintaining safety of Nigerian railway networks by Engineer Igwe Bright, MINS NDT, FinSet, and Senior Technologist PTI. Distinguished ladies and gentlemen, still on the technical presentation segment of this great session, it gives me great honor to invite Engineer Chibuzo Alright, distinguished ladies and gentlemen, it gives me great pleasure to invite to the fore the person of Uchenna Duaka on destructive testing, FI Marest, ASNT Level 3, PCN Level 3. He's also a technical consultant on implementation, boilers, and pressure vessel regulation. And the first vice president of the institute, that's INDTN. Ladies and gentlemen, he's going to be talking on training, that's a training and certification of NDT personnel. Let's put our hands together for him as he approaches.
Good morning, distinguished participants, ladies and gentlemen. Today is day 2 of the conference proceedings on the optimization of critical national assets using NDT. And we have had a series of papers delivered on this subject matter yesterday and today. So right now, we'll be looking at what we need to qualify as an NDT practitioner. Yesterday, we the need and the role of NDT in the application of NDT in most of these critical. We shall be looking at the training selection process and what is happening in Nigeria as of today as far as training as a. So the objective of today's presentation will be to give an insight into the global practice of training and education of NDT personnel. From what we have had so far, we know that NDT is a very, very important link in that cuts across all aspects of engineering. And it's a major part of the process that will make us ensure safety of the process, or whatever process we are talking about. So we'll be looking at what is obtainable internationally, and also looking at the present activities of INDT Nigeria with respect to training and certification of NDT personnel. And then we'll also be looking at how to stimulate interest in NDT training, education, research and development. You agree with me that one thing that is missing in our industry is research. Research is missing. When Dr. Bello presented a paper yesterday on robotics, the use of robotics in NDT, you see that equipment that are involved. And we ask ourselves, in all this, where are we? In the NDT market, there are two major aspects, or rather three. One is the training, to make sure that you have qualified personnel. And the other is equipment manufacturing. And the equipment manufacturing, where are we? Every equipment used in NDT today are all imported. And most of the training, most of the people that are certified are all having foreign certification. And you agree with me that no country will make progress if your certification process is domiciled outside. You have to domicile your certification in country. And that is the only way we make progress. And in this field of NDT, what we have observed is that there are two major power blocks. You have the American block and you have the European block. And they control the market, both training, certification, and equipment manufacturing. China is playing some role in equipment manufacturing today, but not as much as America and Europe. Most of the equipment still come from America and Europe. And so these two blocks control over 90% of the market space. So how do we find our feet as Nigerians? So that is one of the things that INDT is trying to stimulate interest in research, so that we can start to develop our in-country equipment and use them to progress our nation. So we'll be looking at, first, I would like to start with what NDT technology actually is, for the benefit of those that are not the non-practitioners, or for those that need to see a different aspect of NDT. And so NDT technology is defined as an engineering science that interrogates materials using various energy forms, including heat, acoustic, optics, electricity, magnetism, radiology, electromagnetism, or a combination of forms to detect defects. When Dr. Bello was talking yesterday, his presentation was mainly based on advanced NDT, subsea application of advanced NDT. And you saw that the examples he gave, he was talking of sensing. And that is why NDT is seen as the diagnostic toolbox of engineering. And I remember the president, the INT president, when he was talking. Now you ask, who established this method? The power blocks. Americans and Europeans. And so in the American bloc, you have the ASNT, the American Society for Non-Destructive Testing. And in the European bloc, you have the BINET, the British Laboratory Testing. And they operate different certification schemes, which is why. Because even China had to swing with whatever the Americans bring out as far as NDT is concerned. Most of the literatures, books today that are used in NDT are still books written in America. All the handouts are still books written in America. So you have even the British, even the BINET, to write the exams, you still have to make reference to the American books written in America, the handbooks in America. So the ASNT has established these 11 methods. Otherwise, you have over 500 different methods. And any subset of that method is called a technique called advanced NDT. And what makes it advanced is what Dr. Bello explained yesterday. And now we are now in 5.0, or we are gravitating to 5.0. So the advanced method are actually using digital processes. So their data are collected digitally, and you can also store them digitally, not analog. While the conventional ones are the ones I said earlier, the 11 methods, they are still NDT 2.0, which has some analog system embedded in them. So the NDT education there are two NDT education. One of them is the employer-based certification. That means that your employer can actually have a program to certify you. And that program is championed by ASNT. In most parts of the world, that is the program that is being used. In fact, more than 90% of people that are qualified to do NDT today. Consider a company like Boeing. And so ASME gives some form of accreditation to some of the standards that other organizations that collaborate with them produces. So also you have the the Aerospace Industry Association, the National Aerospace Standard, which is the NAS 410. It's also an employment base, but this standard is only within the aerospace industry. It's more stringent. It's more stringent than the normal standard that we have. So the Aerospace Industry Association standard, which is the National Aerospace Standard, is also American. But it's used all over. It's also used in Europe. Now you have the Central Examination Based Certification. here you have an array of certifications. We have also the ASNT ISO 9712. 9712, ASNT has to adopt the ISO standard because that is what is getting popularity worldwide. So ASNT developed a scheme called the ASNT ISO 9712. And you have the ASNT ACCP, which actually is a central ASNT central certification program. The ACCP has been existing since 1975, but you find few people qualified to ACCP level 3 compared with those qualified to ASNT NDT level 3. So the ASNT NDT level 3, though it's a central certification system, but it's actually does not have much practical content compared with the ACCP. They have the ASNT ISQ, which is the industry sector qualification. The ASNT also come up with a system where the industry, especially the oil and gas industry, needs you to be qualified to a particular specific technique, like corrosion mapping, for instance. They don't also say you have UT level 3. Yes, you have UT level 3, but are you an expert in corrosion mapping? Are you an expert in phased array? So the industry sector qualification gives you an additional license, which makes you a subject matter expert in that specific technique. And that is where the world is going today. The world wants to make experts from small things. They don't want you to say you can do everything. No. They want experts in every segment. And that is how they want the world to progress. Then they now say ASNT or ISO 9712. So you have then finally ISO 9712. Now under ISO 9712, it's just a standard which every country is supposed to domesticate. So what we used to know as EM 473, which is PCM 9712, and C-Sweep is also another scheme in the UK. It's purely UK, run by the TWI, the World Institute in the UK. It's also certified to. It's also accredited 9712. They have the ISNT, which is India's. And I'll tell you, in India, if you have ISNT level 3, you earn higher than someone with PCM level 3 or ASNT level 3 in India, because they recognize their own. And so, and in all their government sectors, they only employ those with ISNT level 3. You can have ASNT level 3 as additional certification, but the permanent requirement is that